Hey, Blake. Oh my God, we got Hacker Man in the background. What? Why is Hacker Man there? What? Oh, maybe, I don't know. Maybe it'll appear every time now. Good to see you here, Blake. Good to see you here, Victoria. How are you doing? We'll throw out some points. What questions do people have? We need some music right here. We got music going. We got points. Angel, good to see you there. What questions do people have? Drop those questions in the chat. Start off with some questions. First questions get the first answers. That's how we do it right here. So many things. People getting all those points. Points. Can we go over Canvas content? Yeah, Canvas content number 5 or 6 or something like that. One of those Canvas contents. I think I've talked in so many accents that, like, all of a sudden I merge into one accent. This is what happens when you just you do like New York accents, Southern accents, Australian accents. I can't do it Australian. It's just like it answered, but I'm not super confident my answer is cool. Let's do some Canvas content. I'm getting loaded up as we speak. I've been everywhere and all over the US of A. Here we go. We got some Canvas content right here. I put all the notes from yesterday. Cool. Let me delete. 258. Stat 201, Canvas content number 5. Here we go. Let's do it. So this one is all about regression. If you know the R-squared value, define the correlation coefficient, what would you do? So correlation coefficient is R squared. R squared. Here we go. So let's say, it says if you know the correlation, right? If you know the R squared value to find the correlation, what would you do? So here's our example. You ready? Oh my gosh, it's a curve. R squared equals 0.49. What is R equal to? So find this one right here. R squared is 0.49. Pretty good right there. Yeah, that's good. So can anyone find R? If you know how to solve this, we'll be able to solve the question. And this is a good example right here. Well, if R squared is 0.49, what is R? So think of it, how would we solve this? Don't worry about the answers to the question that exist. We want to understand these things conceptually right here. So if you know how to solve this one to find what R is, knowing R squared, then, and so what would it be? So be careful. You'll see there's a little strict here. Victoria. Ooh, Blake, good answers. Let's throw some points out. Good answers, but there's a problem. So you're close. We're throwing 1,000 points for close answers right there. And this will direct us towards the right answer when we look at the problem here in a second. What's the issue? There's a small issue. Blake, you saw it. So great job right there, Blake. Blake noticed that the sign is an important thing right there because right here you'll notice that we need to make sure we add in the negative to it because it goes downwards. So when you do correlation, you can square root the R squared and get the correlation, but then you need to check the sign right here. So that's very important right there. Victoria sees it too now. Great work. So if we look at the answers to the question right here, it says multiply the R squared value by 100. Now that's how what you do to interpret R squared. You multiply it by 100 and you'd say 49% of the variation Y is explained by the variation in X. That's more about interpreting R squared because it's a percent of variation Y explained by X. Make sure to know how to interpret R squared. Blank percent of the variation Y is explained by the variation X. And R squared is not negative because it's exactly R squared. What's up, Snea? Good to see you here, Snea. We were talking about you yesterday. So good to see you here. 1,000 points, Snea, in the chat. Take the square root of R squared and check the direction. That sounds like the right answer to me. Square root R squared and check the direction. Square the R squared? No, you don't square R squared, square root. Take the square root. So these are your possible answers, but you do need to check the direction. Snea level is back. Snea level is here. Adding together all the residuals from a regression plot will sum to 0 on average. Yeah, that's awesome. That's so cool to hear, Snea. Like, that's what we like. I just like, I don't know, like Zoe was talking about that, and I was like, that's so cool. And so do this. Solve for the last residual. This is called the line of best fit. And so if we have a residual here of -2, which means this might be at something like 3, and the line's at 5, and that's 7, and that's 9. So does that make sense that this right here is 2 below the line? So that's -2. This one right here would have a residual of what? So what would the residual be for this one? Just going that the prediction there is 5, you can see the predicted value y hat equals 5, and the observed value is y equals 9. So what would the residual be for that? The residual for this point down here is -2. It's 2 below the line. So the residual for that one up there would be what? What would the residual be for this one? Like, this one is what? Like, what is its residual? And this is helping us understand what a residual is. So a residual is how far a point is away from the line. So the line predicts 5. The point is at 9. So what is its residual? So what would the residual be? The residual is how far it is away. Like, this point is 2 below the line. The line is at 5. It's at 3. So where is Snea's got all those points? Snea is at... Oh, because I reset the points, Snea. You're just a legend. I should change your points here in a moment if you like. We'll do it between the question. So does anyone know what the residual would be right here? What is the residual of that point? So you have to ask, this point is at 9. Do you see that dot right there? That dot is at 9. The prediction is at 5. Like, it is predicted to be 5. So that's where the prediction is at. So what is the residual? 9 minus 5, actual minus predicted. So the formula, great job right there. Residual equals actual minus predicted. Residual wrap. Oh, no, Snail, we got to fix that. Let me fix that really quick right here. Go over here, bring the channel out here. So when you think about this, the residual is just how much we miss by in our prediction. So the residual is how much we miss by in our prediction. Snea, I fixed your points. Okay. So the residual is how much we miss by in our prediction. So when we have another point over here, technically, we should probably also have another point over here, right here. And mathematically, there is something mathematically that must occur. The residual for this point must be what? Now you can see it, and then I want you to think about it. So what would the residual for this point be? The model predicts 9, because that's where the line is hitting. The line's hitting at 9. The point is here at 7. So it's also E equals actual minus predicted. That's how it's written as notation. So what is the residual of that one? Oh my gosh, Snae's got all those points. Your thing will change. I don't know, Snea just got all the points. You typed in the cheat code. So what is the residual for that one? What is the last residual over here? What is the last residual? Negative. Careful, Victoria. Very close. Not 2. Remember, residual tells us above or below. So this is the negative residual region. This is the positive residual region. And anything on the line would have a residual of 0. Anything on the line would have a residual of 0. -2. Great job. So residuals tell you above or below. Victoria, excellent work. Got 3, another 1,000 points. Keep up those answers and keep up that practice right there. Residuals tell you above or below the line. So when you think it's actually at 7 minus 9, 7 minus 9 is -2. So that means it's 2 below. And I color-coded these. So if you add up these residuals, what do you get? And this is the way residuals work. If you add up the residuals of -2, -2, and 4, the residuals will always sum to what? Which answers our question. So I drew out a theoretical problem right here, which is theoretically accurate. If you add up -2, -2, and 4, that sums up to what? It sums up to 0. The residuals kind of counterbalance. They kind of sandwich in on the model. So the line of best fit will go through, and you notice right here, if you were to add these up, they would kind of like suck into the line right there and be a perfect fit for the line. So adding together all the residuals sum to 0, that's very true. For each 1 unit increase. Now, here's the really great thing. If you get this on the test, if this question appears on your test, what could you use this for? If you're watching Canvas content right now and this appears on your test, what do you have right here? You have a cheat sheet for interpreting the what, which answers our question. For each 1 unit increase in X, we expect Y to increase by B1 units on average. If you get this, you now have a cheat sheet for what? You now have a cheat sheet for interpreting what? This would be so great to get right here. You'd be like, yes, I got the question that's a cheat sheet for this. Oh, I'd love it if I had this. The slope. That's the slope because it's rise over run. So watch what we can do with this. This literally, there are 4-point questions for you. Good to see you right here. And the answer is D. We got 3 more points for that answer right there. This question right here, and we're going to throw a mod right here. Add mod. So this question right here, we're going to bring up a little bit of data. Because on the test, you will need to be able to interpret. You'll need to be able to interpret regression models. So let's predict somebody's gonna find a thing. How much people work based on their age. Okay. So here, I'm gonna make it look nice, and you'll see it in a second here. Does that look pretty? Almost. Okay. So here is a regression model. You'll see it in 2 seconds. Okay. So here's a regression model right here. Just answer these questions right now. What is the intercept of this model? So just what is the intercept? And if you look back here, you could see the intercept all the way down here. What is the intercept? Just tell me numerically what is the intercept. You should be able to see it now. It's not always there in the graphic because we don't always go to 0. It's negative 42, and you see it right there, and you can see over here where it hits. And also that is the estimate of the intercept. Does that make sense to see it down here in this output where it says, this has more decimals, I annotated some decimals, but that says estimate of intercept. You have to like trace down here and trace across here to say estimate of intercept. So we estimate the intercept to be negative 42. That's an estimate of it. What is the slope, which is the rise over run? It's 2.5. So 2.5 is also the estimate of the slope, and I did annotate some decimals. 2.5, I round or annotated to 2.5 right there, and here is the slope right here of 2.5 times x. Now, we call this B0 and we call this B1 for the first x. So where do you see the R-squared value? Boom, right there. Victoria, great answers, and good seeing you, Snea. We got to throw you another 1,000 points. Thank you for being here, Snea. The R-squared is right here, and we can interpret every one of these values. So first, let's use this right here to interpret the slope. So try writing this out. If you are watching this right now, if you are watching this in the future, I want you to try writing out the interpretation on a sheet of paper next to you. We're going to take this regression model right here, this model right here, and interpret it. And I promise you, you are practicing for the test. So if you were to get this right here, all you need to do is find your x. There's your x, then your y. Then find your B1. There it goes B0, then B1. Goes in that order, 0, 1, like we count. Yeah, we'll do that one next here, Victoria. So how would you do this? Use the information right there for the slope to interpret the slope in context of the problem, which is a question on test 2. So this is super awesome test practice we're doing right now. Like, this is test prep right here to be able to be like, I don't want to do it yet. I want you to try to do it. If you're watching this in the future, try writing it down. Try typing it out or writing it down because you will do this on test 2. Like, I promise you'll be like, man, I did that on test 2. I was ready. And if I got this right here, I just got to plug in those numbers. If you get this, you got a cheat sheet on the test. So we'll see what people write. See if you can do it. Then we'll do the R-squared and we'll do the intercept, which are also interpretations. So we'll do those 2 next, Victoria. And great work, Victoria. So what do we have as an interpretation right here? How would we interpret the slope? How would we interpret it? And maybe I'll help out right here. I'm going to write on this a little bit right here. I'm going to write the notation for it. So there's the regression equation. And this is your y. For each 1 unit increase in age, we expect hours work to increase by 2.5, and then just 2.5 on average. That's it. And then you don't have to say times age. You just say 2.5. Great work right there. And then make sure, and then Fareed, make sure to say the full thing. Victoria has it right there. You just say 2.5. So it's like for each 1 unit increase in someone's age, we expect them to work about 2.5 hours more. Does that make sense? So for each, Evan, good to see you here. For each 1 unit increase in somebody's age, because that's the X variable, we expect the hours that they work to increase by 2.5 on average. Does that make sense? for each. Yeah, so that's what you say, and you don't have to say times x because it's just the b1 is the b1 right there is 2.5. So you don't do the times x. So just think about making it make sense. For each 1 unit increase in age, we expect hours work to increase by 2.5. Victoria, 1,000 points. That's exactly it. And does it make more sense as you say that right there? For each 1 unit increase in someone's age, we expect the hours they work to increase by 2.5 on average. That's exactly it right there. Like if you do that on the test, and if you get this right here, you just got to plug in and know how to use the equation. So that's where you get the practice right there, and you know how to write it for the test, and you're good to go. So now let's do the next one. Let's do the intercept, and let's see if it makes sense. So let's do the intercept and see if it makes sense. The intercept is when x is equal to what? Mathematically, the intercept is when x is equal to what? So mathematically, the intercept is when x is equal to what? So mathematically, the intercept is when x is equal to 0. So pretty much, if you know that mathematically, you can interpret it. When someone's what is what, we expect their what to be what. And then we could make a comment on that being logical or not. This is really good test practice right now. When someone's what is what, we expect their what to be what. And so look over here, you can see the answer to the question. When somebody's what is what, we expect their what to be what. And then let's comment on that being logical or not. When somebody's, repeat it again right here. When somebody's is we expect their to be So what is it going to be? When someone's age, very close, Victoria. When someone's age is equal to 0, and then plug in the values. When someone's age is equal to 0, we expect their hours worked to be equal to negative 42. When we speak everything here at Stat 201, which is illegal as babies don't work negative. If you added that in, Victoria, that would, if the grader didn't give you points for that, I would crack up and I would be like, of course you should get points for that. Of course you understand. Like we're talking about babies working negative hours. So when someone's age is equal to 0, we expect their hours work to be negative 42. And Victoria, I think that's the perfect answer. We got through another 1,000 points. These are excellent answers today, Victoria, and really good practice to then be like, yeah, that doesn't really make sense. Babies working negative hours. That's exactly what you could say on the test to be like, it's an illogical intercept. Does that make sense to say why it's illogical? A lot of people say, well, what do you mean by an illogical intercept? It means the interpretation just doesn't make sense. It's like when someone's 0 years old, the 0-year-old person should work negative 42 hours. Well, with 0-year-old people don't work, and negative 42 hours is not possible. This is a very extreme extrapolation of the model. So really good answers right there. And so if you saw, we also had a reason that mods exist. The mods probably saw that. I got it. I hid the user on the channel. Bots. So next we get to the R squared. I wish we could do negative work hours. I wish too. It's like you get time back. So now we have the R squared. Yeah, I know, right? So how do we interpret the R squared right here? How do we interpret R squared? When you interpret R squared, you times it by 100. And be writing these down as we do them. So we have interpretations right here. Our first interpretation was the slope was for each 1 unit increase in X, we expect Y to increase by B1 units or decrease, increase/decrease, depends on slope direction. The intercept was intercept when X is equal to 0, we expect Y to equal B0. And the R squared, you're on the right track. Blank % of the variation in Y is explained by the variation in X. Some teachers want you to say on average after this. The expect means the same thing to me. Honestly, no idea what the problem is asking. I just answered which one, Evan, right there? So we're going to interpret right now. If you're wondering what we're doing right now, we're interpreting the R squared. So we have to say blank % of the variation in Y is explained by the variation in X. And these are the things you want to input right here. Like if I bold and underline it, you will be replacing those with context of the problem. So you had 6%. Do you remember the X and the Y, Victoria? If you remember the X and the Y, go ahead and plug those in as I'm giving everyone what to write down. You want to have this written down. You want to memorize these. Sometimes you get a little help on the test. It might explain it. Do you want to pick one of those? So I'm making this so you could know what we need to pick between. And you probably want to give context to 1 unit increase. These are like the general interpretations. So we're going to try to interpret the r squared in context of the problem. You will need to write these down during the test. So the r squared that we have over here, let's go back to the output, is 6%. You could say 6.0% of the variation in hours worked is explained by the variation in age. Boom. Victoria, that's it. You're done. That's it. Blank percent of the variation y is explained by the variation in x. That's it. That's all it is. You did it. Yeah. That's it. It's r squared. Don't say it's correlation or anything. Whatever you do, don't be like correlated. No. Don't do correlation. A lot of people say Wacky Wednesdays. We'll throw some Wacky Wednesdays up here in a moment. It'll be our congratulations for finishing this Canvas content. Is if the residual is this and the observed is this, what was the predicted value? Notation's going to be our best friends. Ooh, you're going to get there soon. Notation's going to be our best friend on this. Notation is going to be our best friend. Where's our notation brother?
Notation brother.
Thank you, Leo. That's from Leo from last semester. Notation brother. So what is the notation for residual? You could call it R if you want. The two possible notations are either R, or you could say it's E. That's the more classical notation. Predicted, you could call it P. Predicted is Y hat. And the observed, so I like to call the observed the actual. Yeah, that's right. Good. And then it's Y. Okay. So these values, I have it written with 2 sets of notation. The reason being is, what is the formula for residual? Using RAP, it might be. The residual is that, the observed is this. What is the predicted? So the observed has to be, I think you got it, Victoria. Really good solve. Yep. And I like to say RAP. So I like to say residual RAP. So I spell out RAP, residual equals actual minus predicted. But in classical statistical notation, residual is E, and then actual is Y, and predicted is Y hat, which comes from the model. So the line itself is going to be the line of prediction where all the Y hats come from. The dot is the Y, and the prediction, or the distance it is away, is the E. So that's right there visualized for you. Like the line makes a prediction. So the prediction would be right here. The dot of where it's at is going to be the actual spot. That's the actual. And then the distance it is away is the residual. So the residual is the miss. So actual minus predicted. So I think you're right. We literally just would plug in the numbers right here. So we would take our formula, and residual equals 1.1 equals, and we have the predicted value. So the predicted, what is the predicted? Oh, we don't know that. Minus P, and 16.6. So yeah, you might have it, like, that is correct. And you can just algebra this out to subtract from both sides and then flip it, because you'll have negative P. So if you algebra it, you will get, subtract 16 from both sides, 16.6 from both sides, you'll get negative 15.5 equals negative P, and then 15.5 equals P. And then what could you do to check your work right here, Victoria? Like, if you're like wondering if you got this correct, what could you do to like be like, did I solve this correctly? Like, if you're like, I don't know if I did my math correct, I don't know if I solved P correctly, plug it back in. Is that, and please do that. Like, double check your work. So oh, thank you, Evan, right there. I appreciate that. Some people have said, like, we should have some ASMR. We should be like, welcome to Stato. I can't do it. See, if I try to be calming, it's not going to work. So do some Stato. Evan says, I don't know, Evan. Evan does not like, that's scary. It is
Halloween.
Not yet, but this month. Need to get a good costume for this month. The natural Brian is coming. Find the predicted value using a regression equation. So here's some notation for us. So let's write our regression equation. What is the regression equation? How do we write the regression equation? Brian calming is cringe, is what I say. What is the regression equation? What do B0? They are the estimate of the intercept and the estimate of the slope. So do I have those? I don't have those notes open for yesterday. I have the 320 notes. B0, and they're technically lowercase b0. So this here is what we estimate the intercept to be, and this is what we estimate the slope to be. So visually speaking, you would need to have a model that where x is equal to 0, it's going to be up here and hit at 11. So that is, or it's going to be weird if I do that. It's going to hit here at 11. And then the rise over run of this is going to go to 14, 17. There we go. So does this make sense right here? So this is the rise over run. Oops, wrong color. So the rise over run is 3. I might have made the units not look right. So that's a 3-unit difference. And then the intercept, I didn't make it hit. Oh, so this should be 0 then. There we go. So does that make sense right there? The B's, great job, Blake, right there. Amazing notes in the chat, Blake. 1,000 points, keep it up. That's in Blake. Evan and Blake are getting there to the huge points, crazy totals. B0 is the estimate of the intercept. So that's where the intercept is. And just take a look at the model we made moments ago. Does it make sense that this model right here, B0 is negative 42? Does that make sense right there, Victoria? If you see B0 right here is negative 42. So when x is equal to 0, the model, it's hitting right there at about negative 42 if you look at where it hits. And then 2.5 is the rise over run. That might be hard to see, but there's a rise over run of 2.5. So nice job, Blake. Blake, we should throw a Blake level in after this. We'll throw, if you want Blake. I know, right? Well, that's the first person of the semester, I think, to get to the 500,000. Good to see you, Wes. So Wes is trying to get there too. Our goal is to get, the goal is if you attend class, you should get to the 500,000. So I try to pace everybody and figure out the right amount of points. But if you attend every class, I want you to get to the 500,000, like, or most classes. If you attend like 7, 80, 90, 80% of class, I want you to get to the 500,000. I don't want it to be something out of reach for people. So we kind of try to push it in that direction. So yeah. So with this right here, we need to write the regression equation. Write the regression equation for me. One, Tony. Write the regression equation. Who can write the regression equation? Like the y hat equals something. Write the y hat equals. We'll throw some points for everyone. While you write the regression equation, tell me what the regression equation is. Now that we know B0, B1, great job, Evan, right there, already writing it. Now you do, which is fine. You do have it in the y equals mx plus b format, which is okay. It's okay. It's okay. It's okay. We write y hat equals B0, and that's when x is equal to 0. Good way to remember it. Plus B1x. So y hat means the predicted value, which are the values on the line. These are the predicted values. So we are trying to make a prediction right here. So we're going to make a predictive value where B0 is equal to 11. And then we have right here B1 is equal to 3. And this is equal to 10. So what is the predicted value going to be? What is the predicted value going to be right here? You could write it either which way. Because a hat, yeah, no imperial. Hat means predicted where y means actual. Like a point is a value of y. And a y hat is the prediction. And then the residual is how much we miss by, which that residual we could estimate in a moment. Does anyone have a guesstimate of what the residual is? What would you guesstimate? Just visually speaking, what would you guesstimate this residual to be, which is E, which is the difference between the actual and the predicted? Visually speaking, what do you guesstimate that residual to be? Just don't worry about it being perfect. Just it's about this. And then what does that mean? Which is a separate question. What does that residual look to be? Just a guess. Like, it's about this. And then we think, well, what does that mean? When you say it's this. How would you guess it? So the residual is how far a point is above or below its prediction. So here's the point itself. And so how far is that point above or below its prediction? So you have to look where its prediction is at. Maybe its prediction is right over here at about 12-ish. We'll say 12. About 5. There, you just did it. That's literally it. It's about 5. And what do you mean when you say 5? Well, it's about 5 higher than we predicted it to be. It's about 5 above 12. Yeah. That's what a residual is. It's how far above or below the line the point is. So that point is about 5 above. How about this point over here? What is the residual of this point? So if you were to look at this point right here, what is its residual? So look at that and kind of look at the similarity on what I did with this one. That point right there might have a residual close to what? Nice job, Victoria. That's what we like to see. And good practice learning this stuff right here. So then what would that be? You're exactly right there. Good guess, Victoria. Close. -5, Angel. And if you have questions, drop them in the chat. -5. And think about this, because look, this is like the same distance. Oh, I can't draw. That's like the same distance, right? It's like the same distance, but it's below its prediction. Like it was predicted to be up here from the line, but it's actually, because the y is where it's actually at 12. So it was predicted to be at about 17. So if we do actual minus predicted, we get -5, meaning it's 5 below. And then you do add the negative sign, because residuals can be negative or positive. And then what do all the residuals sum to? We only have 2 residuals right now, which makes this mathematically work. The line wouldn't look like that. The line would actually go down. But the residuals right now, we have 5 and we have -5, which actually holds to the relationship of residuals. Residuals all sum to 0. Now, we would need to add more points to make the line work correctly through this model, but the residuals will sum to 0. They will kind of counterbalance each other. And to think about the way that looks, you have a lot of models that would look something like, I drew one right here, like this, where you have a bunch of residuals above the line with positive residuals and you have a bunch below. So above the line, which means your actual is higher than your predicted, is a positive residual region, and below the line would be negative residual region. And so great job, Victoria. Should we do one more version of this, or what other questions do people have? This was a really good test relevant review of everything you need to know for, not everything, but like a good vast majority. Well, if you're looking for a good review, I think this was really excellent. Like we covered a lot of stuff. Congrats to Victoria again, that 10 out of 10. How do we interpret residuals? So how would you interpret, good question right there. How would you interpret this residual right here? We maybe are predicting how many push-ups someone can do. Someone can do, think about this, we're predicting push-ups. And so we predicted someone could do 12 push-ups. It's just wacky things. It's due on Monday, I know, right? Got a lot of practice. So we're talking about just this one over there that I have highlighted. So what does the residual mean? What does that residual of 5 mean? What does it mean? That's such a good question. We're throwing some points to Wes right there. What does that residual mean? Yeah, what do you want to know, Isabella? Drop it in the chat. Got more than enough time. We should switch to that here in a moment. What does that residual of 5 mean? And this is kind of 320 related, because it's regression. What does that residual of 5 mean? We're predicting push-ups. If you know the R-squared value, to find the correlation. That is correct, Angel. Yep. And we did that one earlier. We talked in good detail, Angel. So yes, correct. So what does that residual of 5 mean? It means that the amount of push-ups someone could do, which is their actual, was 5. Not that you do between 12 and 17. Someone could actually do, so that is where they actually are at. Does that make sense? They actually did 17 push-ups, so they're super strong. They actually did, no one's ever done 17 push-ups. So they actually did 17 push-ups. They were whatted. Down here, they were whatted. What does that mean? They actually did 17 push-ups. They were to do push-ups. So they actually did 17. 47. Nice. 11. That's correct. That's good right there. They actually did 17 push-ups. They were what? They actually did 17. That's their observed value. That up there is their point. They actually did 17. They were, what does this mean down here? They were what? The line makes what again? They actually did 17. That's them. They actually did 17. That's what they did. That's their observed value. They did 17 push-ups. But the model predicted them to do 12. So they did They were predicted to do 12. So the amount of push-ups they did was what? What does the residual mean then? They did what? Because it's the distance that the actual and the predicted are away. So think about it. That means they did what? They actually did 17. The model predicted 12. So they're above what they were predicted to do. But what does the 5 mean? I mean, they're above. They did 5 more than they were predicted to do. So they are 5 higher than the model predicted them to be. So they were predicted to do 12 push-ups. They did 17 push-ups. So they're 5 higher than their prediction. Does that make sense? Like visually, to think about it right here. Like they were predicted to do 12. They did 17. So they are 5 higher than their predictions. Like, oh, I think you'll do 12 push-ups. And you do 17. I was like, well, I was off by 5. You did 5 more than I expected you to do by the model. Does that make sense? Like what a residual is, it's how much we miss by. Awesome. We got the office hours gang right here. And thank you to anyone watching this in the future. I know a lot of people watch these in the future, which is really awesome. So that's just how to interpret a residual. We could, if you want, there was a question about 320. Drop the 320 question in the chat. Be like, hey, Brian, can you work this? Let me know. We've got another like 20, 25 minutes. Let me know what you want to understand. What kind of speed, got the hiccups. We'll speed run. Brian's weather in Texas is kind of depressing today or not? It's been decent. We've had decent weather. If the residual is negative 2.3, so that means we're what? We are what below the predict? Are we? So if you think about this, if the residual is negative, here's the prediction line, right? Does that make sense? This is a line. And then our observed would be below the predicted value, right? So what do you, just think to do it in your head real quick. You can write out the equation, which we did some of these earlier. Can you solve it in your head now, just thinking about it? Ooh, reverse it. I'm pretty sure it's reverse. Because what you want to do now, if you think, good work there, Evan, I'm pretty sure it's the reverse way. We're going to throw you 1,000 points, but we're going to check our work right here. Because it's either, like, you either need to add or subtract it, and that's where we check. Oh, then we'll go check, and we got the answer right there. Good question, Isabel. We'll do that one next. Isabella. So here we go. Let's check it out. You ready? Residual in notation is R. I like to do it as R right there. The observed is the actual. The predicted is P. So we're solving for P. So residual equals actual minus predicted. So negative 2.3 equals 29.1 minus, and then P right there. So think about this. If you plug in 26.3, then you will get a positive number right there. So what we need to do is we need to, so residual equals actual minus predicted. So one way to solve this out, 31.4, yep. You can subtract from both sides and you'll have to flip signs, but not negative though. It'll be, you would subtract it, but this is not negative P, it's just minus P. So like it's not, we're subtracting this. So we're solving for P right here. The predicted value was this. And so you subtract it off. So it would be 31.4. And then think about this conceptually. That means, so great work right there. It's an algebra problem right now. So when you think about this, the observed was what? 2.3 what to the predicted. So think about this, what the residual means, and then interpret it. The observed was what? Like, finish my sentence. The observed value right here is what to the predicted. Not above. Remember residual is above or below if it's negative. The observed value, since it's negative, the observed has to be 2.3 below the predicted. Does that make sense? So this is the deeper conceptual learning. So since it's negative, the observed value, see how I'm like making a point right here? The observed value right here, the point is 2.3 below the predicted. So when you look at your predicted right here, the observed should be 2.3 below it. The observed is 2.3 below the predicted because the residual is negative. So the residual tells you how much above or below the line you are. The line is the prediction line, and the observed is the actual point, which is a dot. So if it was positive, then it would be 2.3 above the predicted. So good practice right there, and that's the deeper understanding to be able to like communicate it. To solve the formula is just one set of understanding, but the deeper understanding is like communicating the idea. If the residual is positive, what was larger? So think about this. When this one did have an error, we got to watch out because this one at one point counted the wrong answer. So we're about to find out the hard way if we get this right or wrong. So I know the ones we've made mistakes on in the past. Haha. So if the residual is positive, the point is up here and the line is here. So this is the positive residual region, the actual, exactly. So what Blake's mentioning, great job, or is that Evan right there? Thank you, Evan, right there. Great work. Evan's mentioning that these points right here is the positive residual region when your actual point is above the line of prediction. If we get this one wrong, I'll need to be correcting it. Let's hope we get it right. Like, that is the right answer. If the correlation coefficient is equal to 0.5, what is r squared equal to? So what is the complicated formula with r to get r squared? Like, if we have a correlation of 0.5, how do we get... Oh, we got to throw some points. You got it. If we get a correlation of 0.5, how do we get r squared? How do we get r squared? It's r squared. Yep. Oh, that's it. That's all it is right there. If you know the value of r squared, define the correlation coefficient. So once again, so don't get tricked by this one. Great job, Victoria, right there. Don't get tricked by this one. Are you ready? This is the tricky questions. So here is... What is r squared equal to? I mean, what is r equal to? I'm tricking you. Watch out. Is it? Ay, ay, ay. Good to see you, Sarah. Good to see you, Roshni. Now, watch out. I've tricked you. You are tricked. You got through 1,000 points for getting tricked. Don't worry. What is the trick to this? Who knows? Someone will get it right here. Don't worry that you got it wrong. The good news is you won't get it wrong in the test. Oh, you're closer, Sarah. Good. Sarah, closer to the right answer. So r squared, to find it, Sarah's closer. Sarah's on the right track right there. So what do you want to do to r squared to get r? What do you want to do to r squared to get r? To get r from r squared, what do you want to do? Sarah sees it. Sarah, another 1,000 points. You got it. So you want to take it and you want to square root it. So you say, well, the answer is 0.8 then. Sarah sees it. What do we need to know? Because when we square root something, what should we check? Because correlation indicates direction also. So correlation is different from r squared. R squared is always positive, exactly. R squared is always positive. Correlation indicates direction, exactly. What condition looks to be violated on this plot right here? What issue is there on this plot that looks to be an issue? I do a little extra thing in here. What looks to be the issue with this plot? What looks to be the issue? Plot does not thicken. Yep. When all starts. Yeah, that's the whole point, is like we solve these. So hopefully, so take the square root and check the direction. So we practice and we solve them all right here to make sure we can get it. We don't want the plot to thicken. Consider this output right here. What is the r squared? The r squared is literally that value right there. Just so you can see, that's the r squared. It's not r squared adjusted. So that's the value of r squared. And this, here's the thing. If you get this on the test, I want to point to some things. You will need to interpret stuff on the test. This right here is an interpretation. This is right here the correct interpretation of r squared. 34.41% of the variation in time, and then I like to say is explained by the variation in age. It's associated with is fine too. You can use this, and it's blank percent of the variation in y is associated with the variation in x. You can use this as a cheat sheet right here for your test. This right here is r squared percent of the variation in y is associated with the variation in x. I say explained by because then I can remember is explained by x is an easy way to keep it memorized. Now the slope right here, the slope is the B1 coefficient. So just tell me, what is the slope right now? So my only question right now is, what is the slope? Then we're going to do some 320 right after this. What is the slope? Look at this right here and tell me what is the slope, which there's also down here. Did we include it? Oh, we didn't include the, oh no, there it is. There's the estimate of the slope. What is the slope? You can abbreviate it. What is the slope, which is different than interpret the slope. What is the slope? You must first know y hat equals b0 plus b1x. It is that right there. Great job, Evan, typing all those numbers. You got 3 points for all those numbers. So, and a little bit of plot thickening down there. So the slope right here, they don't interpret, so you can't take it. And then the intercept is the b0, and even shows you 156. That's the estimate of the intercept. And we don't get interpretations for them. We could definitely use those if we had it. There's the 156. As long as that residual one isn't wrong, please tell me it's not wrong. It's fine, because it was wrong on one of the test versions. Good, 10 out of 10. Good. A little worried there. You got it, Evan. Keep going there. We're going to do some 320, but 320's got some crossover here. Let me look at Isabella's question, and let's do some 320. Awesome stuff. What's the difference in the R code for predicting just one individual versus predicting a group of people? For example, all males versus your friend. Okay. Let's go take a look at that. Here we go to the main screen. 320. This is BAS 320. Confidence versus prediction intervals. So this is related to regression and when you would predict for one individual versus when you would predict for a group. So let's say we want to retract it. Let's say we go over here. Got so much stuff. Bunch of data. Woo. Buzz, buzz. Okay. So let's say we make a model predicting someone's height. I like to use this example because it's easy to understand. From weight, from data equals survey 10. Got to load up the stuff. Library red class. Data, survey 10. There's our model. As a mod, I still don't know how to retract other people's. Don't worry about it. Probably can't do it if they're mods also. Big Power has no idea how to use them. You go over those little dots on people, and probably if they're a mod also, you probably can't do it. So that's why everyone's mods. But if a bot comes in or something, we just move the bot. So when you think about this, this is 201 right here. Take a look. We have a model right here predicting people's heights from their weights. Does that make sense? People's heights right here are predicted from their weights. The red line is the predictions. So I weigh about 200 pounds. I would be predicted. Let's do it right here. We can get the summary, and we're doing the exact same things we were doing in 201 a second ago, where we'd have to write out the regression equation by taking the B0 right here. So Brian's height is equal to B0 plus B1, and then we have to add in the weight. So we can easily make predictions right here. Let's say my weight or something like that. And if we enter in my weight right here, and we'll say predicted height, let's enter in a value for my weight. My weight is equal to 200, and here is my predicted height right there. Does that make sense? 42 pounds? Maybe. If we predict for 42 pounds, which would be an extrapolation of the model, we can get your predicted height right here. And does this make sense, Evan, right here, that we're just doing the same things we do in 201? We'd predict you to be about 5 feet tall, 4 foot 11.42 inches. So we can use this model. This is literally just y hat equals b0 plus b1x. Now, here's the beauty of using code is we can actually do these predictions using the model, and we would make a data frame. The data frame, we're going to see how this applies to your problems right here. The data frame is going to have a data frame with your y variable name of interest, which is weight. And then we usually concatenate a vector for the first one and the second one. And then we make predictions using our model, new data equals, and we put in the data frame. And here we go. Do you see how these are, everything we did right here is the exact same thing I did by solving it out by hand. I wrote the equation. So this is y hat equals b0 plus b1x. And then using the code, this is one of the few instances I don't like putting on a new line. Using the code, I say, make predictions using this model, this red line right here, use the new data I'm giving you, where the first person has a weight of 42 and the second person has a weight of 200. The model probably is not that good at predicting people at very low weights because it's an extrapolation of the model. There's no data down there. So now the thing is, why am I blanking on the code just a little bit? It should be interval. Is it interval equals prediction? I always forget one or two things every once in a while. Now we have to think about, this is just a prediction, right? But think about this. We probably have an amount of uncertainty. Like, I'm not saying you're exactly that. It's probably within a certain region. So we have two types of intervals. I hate that it doesn't do the autocomplete. It is good. And here's the second one. That's prediction and confidence. So here's the two set of intervals we use. And let's differentiate between these two intervals. This fit right here is the what for the person at 42 pounds. This fit is my what for them. That is the model's fit from the line of best fit. That is my whatted value for the person at 42 pounds, which is the first person. Not quite the actual. That is the predicted. Good, Evan, thank you for being here. We're throwing you 2,000 points, Evan, for just practicing. This is 320. So that is their predicted. That is the predicted, because that's what we predicted from using the equation, and now the code is doing this for us. Does that make sense? So a prediction interval gives you an interval for the prediction. Does that make sense? So this is an interval for one person's prediction. And I could say I am 95% confident, and we could even make it more apparent that this is a 95% confidence interval by going here to level and saying level equals 0.95, and that means it's a 95. It was originally, but I'm just adding this on to make it more apparent that these are 95% confidence intervals by including the level code. You could make different confidence intervals if you wanted, but I just want to make it very, very clear that these are 95% confidence intervals if anyone's looking at my code in the future. So there is a 95% confidence interval to say, I am 95% confident that a person who weighs 200 pounds, that was my second person, that we put the second person weighs 200 pounds, I am 95% confident for my prediction that the person who weighs 200 pounds will have a height contained between 64 inches to 78 inches. I'm rounding it a bit. If I'm doing it in a paper, I might just copy paste these numbers. A prediction interval is to predict for one individual. It's a prediction for one individual. The prediction interval is actually visualized over here on the right side with these lines right here. Here's the prediction interval, and you'll notice 64 to 77, if you go to 200, is where we would hit, and we'll show this visually. The prediction interval right here on the screen, 64 to 77, is over here, 64-ish, if I could draw better. It should hit right there about 64. Let's trace over at 64.01. So right there. Boop. Right there. There you go. That's 64. And then over here, the 77, if you trace right about here, that's about where 70 or 78. So that's about where it's at. If I could draw better, that'd be even better. But that's the prediction interval right there. Now, the confidence interval is this one down here, and this is for the slope of the line or for a group of individuals, for all individuals. So the confidence interval is this little tiny, I was going to do it in blue right here, this little tiny interval. That's the confidence interval. And it goes from 70.5 to 71.5. So 70.5, so it's hitting about right there-ish. It's so weird. It doesn't look like it hits there, but it does. So it's reporting 70.5. So right about there, I guess. There, yeah, there it is right there. And then 71.5 right there. So that's the interval. And that is that interval right there. So it's being visualized for you on the right. So the confidence interval is for all individuals. That is a confidence interval for all individuals, which is much tighter than the prediction interval for one individual. This is one person. And what do you notice about most of the dots? Most of the dots, which are individuals, are contained within what? The confidence or the prediction interval. So here's the prediction interval with the dashed lines. Here's the confidence interval. Most of the dots are contained within the what interval? Most of the dots, which are the individuals, are contained within the prediction interval because the prediction interval is for individuals. Great job, and great job there, Amanda and Evan. If you have more questions, drop them in the chat. So what we've learned right here is we can use our model, and this is the same thing we're doing in 201, we can use our model to make prediction intervals to say, well, If someone weighs 200 pounds, they're probably between 5'4" and 6'6", which is pretty crazy. That's a pretty wide interval. You say, yeah, they're probably between that. Probably people who weigh 200 pounds are probably somewhere between 5'4" to 6'6". Pretty wide interval there, Brian. Well, it's a prediction interval. It's going to give you a lot of values that they could be. Our best guess is that they're 5'11". So that is from the line of best fit, which is where the line goes through. That's right there. So that value of 71 is where we would hit right over here. So we're visually, it looks like we're lower than that. Let me add in a line. Let me go to this visualize model. Visualize model, because I feel like AB line 71 or H equals 71. Well, I'll be. Look at that. There you go. And line width equals 2. There you go. It hits right there. I just have bad eyes. There you go. And then you could add a horizontal. Go here and go AB line. Vertical, I meant. 200. There you go. That's smack dab where the prediction's at. So, I stand corrected. I know, right? Yeah, no, it's correct. It's there you go. See you in class. So that's where it's making the prediction. If we add in the more decimals, we can probably make it even look more accurate. But so it's actually at that right there. It barely moves. But yeah, that's the cool thing is that you can just use the graph to add in lines, whatever you want. So I love. Oops, we're zoomed in kind of weirdly. But you can kind of check your work. You're welcome, Isabel. So Isabella, yeah, and thank you for being here. And please ask those questions anytime. The prediction interval, the code right there that I have written, is for one individual. So you have to make a data frame of the values you want to predict. So the code right here, I'll drop it in the chat. And feel free to jump any of these questions on the Discord. This is a great question right here to ask. Like, how would we make prediction intervals for one person? Well, that's a prediction interval. How would we predict for a group of people? That's a confidence interval, which is the tighter interval right there. Any other questions? So that's the difference between a prediction and a confidence interval. Confidence interval is for the group of individuals or the mean of the line, like all individuals. Confidence for everybody. Prediction for one individual, one singular prediction. Just writing that down. Couldn't be me. And yeah, the cool thing is this is how easy it is to make predictions using this model. All you have to do, speed run upcoming lecture. Sure, we'll talk about radio real briefly. Because what's interesting is a lot of this is related to what we're doing in 201 right now. Like everything you're seeing right here is all 201 related because we have a line right here. Do you want to versus Brian Stevens? Oh, the chapter 2. I used the voice. I was like,
Chapter 2.
Begin. Yeah, so epic rap owls. Do you want to see how easy it is to get all the residuals right here? You know how we're looking at residuals right there, like that residual, like this distance right here? How easy is it to get all the residuals? Residuals, there you go. There's every residual. Hey, Brian, I can't seem to get through it. I've used length, which percent, which one are you getting? This 474, it sounds like, with the percent A and percent. We'll do that one real quick, Avery. So with code, everything's so much quicker. Sounds like you're trying to subset or something with percent A and percent. You're trying to get like a subset of items. So it sounds like you're trying to subset maybe bands or something. So you're trying to subset bands, it sounds like probably. And you're trying to get, when you use the subset, you're subsetting items. You have to do subset, subset, and then you go G or whatever your thing's called, like music maybe. Then you have to say items, percent, AIN, percent. If you want to do their all in, then you have to create the vector of items you want. And this would subset only those right there. That might be what you're looking for. You might have to message me or something. But something like this is probably what you're going for. You have to use the items right here, if I remember correctly. It's always weird to me that you have to say items. But that's what you have to do. Do I have the A rules loaded up? Yeah, it's an A rules thing. Does that make sense, Avery? You might have to message me it on Discord. I'm going to message 201. Say, class in 15 minutes. Message me. Ay, ay, ay. I got a good bit of sleep last night. But I swear, I am always tired. A little bit of chill music. I need chill right here. Chill music. So The biggest thing with regression, I did mislabel a class. Let me relabel this. Should be 13, 14. Like how my classes are labeled properly. Got 6 people waiting. There we go. Classes are properly labeled. We're 14 classes into the semester. 14 classes in. Class in 15 minutes. See you soon. Click here. If I don't send the announcement, people don't show up. There we go. Good to go. It helped. Awesome. Little Soul has Amazing Chill playlist. I wonder if I could play them. But that speedrun though? All right, let's do a speedrun. You ready? I think I have it. Here we go. Oh, it's wrong screen. I'm so tiny over here. So tiny. I don't like this screen. I thought I had my speedrun thing on here. I thought I had it. That was anticlimactic. We're always doing anticlimactic things here. Awesome. All right, so let's do a speedrun. You ready? Chapter regression. When it comes to the regression chapter, the first thing you need to know is we're trying to make a line. So to make a line, especially inside of R, we just go right here and we say something like miles per gallon, which is our Y variable, is explained by the horsepower of a car, and then we give it a data set. So now we have our regression model, which is just a line, and we need to visualize it. One of the most important things about regression is that the relationship here is linear. Now, if you notice, we might actually have a little bit of a problem. And what's really great about upper level classes is we can actually quickly investigate the non-linearity of it with things like polynomial order or check regression. So check regression allows us to do things like seeing if the linear model is appropriate, and we see the linear model is not appropriate due to the failing of the condition, and we also see that there is not normality of the residuals. Check again, we got a QQ plot for normality, also known as a normal probability plot, which is the plot that shows us the probability it's normal. And look, we got some deviations over here at these high points, which are not normal. So with this right here, we are building this linear model and we need to summarize it. There's key things we need to know with the linear model though, and that would be the slope and the intercept. The notation for the slope and the intercept are going to be B0 for the intercept and B1 for the slope respectively, because B0 is when x is equal to 0 and B1 is when for each 1 unit increase in x, stat 1 interpretation. Now, when you think about interpreting this, you need to know how to interpret all of these values. For B0, it is going to be when x is equal to 0. So when a car has 0 horsepower, which would be a car that does not exist, a car needs horsepower, but when a car has 0 horsepower, we would predict that it would have 30.09 miles per gallon, because that's the Y variable of interest. The slope is going to be for each 1 unit increase, that's for the 201 interpretation. For each 1 unit increase in horsepower, we expect the miles per gallon to decrease by 0.06823 on average. And you notice there is a negative relationship right here. So that is the interpretation of both the slope and, the intercept respectively, and the slope right there. And we need to be able to write out the model. The model is going to be the predicted miles per gallon. Predicted miles per gallon is equal to 30.09 plus, well, it's going to be negative 0.06223 times the horsepower. So we could simply go right here and give a value of horsepower, and the value of horsepower equal to 10 gets us the predicted miles per gallon. Now, what we also need to know is how to get the residual. Something might actually have an actual miles per gallon of something like 20. So if it had an actual miles per gallon of 20, we could take the actual and minus the predicted and get the residual and see their difference. That's all a residual is that's telling us that the actual is about 9 below. So it might have been somewhere around here. Did we predict? We predicted a horsepower 10, so we should probably predict at a horsepower of like 100. And now this gets 23. You notice right here at 100, it's over here at 23. That's where the red line is at. So let's plug in about 19 where that one is at. And that's still going to be a negative residual, meaning that this point is about -4 below the line. The residuals being negative means the point is below the line of prediction. A residual being positive, like over here, means it's above. That has one of the highest residuals, and this has one of the lowest. Points on the line have a residual close to 0. What else do we need to say? Well, once again, we have other conditions. The 4 conditions are going to be QQ, straight enough, no outliers, plot doesn't thicken. Plot doesn't thicken is known as heteroskedasticity, which means the plot's either fan inward or outward. We want about constant thickness throughout the model. One last thing to interpret, which is very important for your test, is going to be the R squared. The r squared value is found right here. It's just literally what is called r squared. You times it by 100 to find 60.24% of the variation in miles per gallon is explained by horsepower. It's blank percent of the variation in y is explained by the variation x. And if I've gone too quickly for anybody, we did write down a lot of these interpretations today while practicing them. We should have them here somewhere. We were writing them down. I know we wrote them down. Where did we? There they are. We wrote them down right here on the slope interpretation, the intercept interpretation. Colin, good to see you here. We're doing a speed run. And we did the r squared interpretation right there on how to interpret those values in context. The intercept, the slope, and the r squared all need to be interpreted in context. This is also a statistically significant slope. The p-value of the slope is the significance of the model because the slope is the xy relationship. So p-values being probabilities, and that is the significance of the model also down here. We really only need to care about this one in the univariate world. And that's most of the concepts. Just knowing that output right there and what it means. I didn't go over standard error, which is uncertainty. That's more of a 320 concept. The t-value is the estimate divided by the standard error. The residual standard error is the root mean squared error. Root mean squared error, correct. Root mean squared error, which is the typical miss the model makes. Oh yeah, this is just extra accoutrements. And then the multiple r squared is the percent of variation y explained by the variation x. The r squared adjusted is r squared after being penalized for the amount of variables we add into the model. It's a much fairer way to look at our r squared. The f statistic is the ratio of what we explain versus what we don't explain on average for the model versus the error in the model, the residuals. And the degrees of freedom are just used for the f distribution. The p-value is the statistical significance of the model. That's everything. Oh, and here's the values of the residuals. The biggest residual is 8.23. The smallest residual is -5. Small meaning most negative. Small residuals are generally considered things that are closer to the model. You want residuals to be small, and you want your symmetry among the residuals, hence why that is shown in the output. If you want a much more in-depth look at this output, I think we did it yesterday during office hours. And so we went through each one of these and specifically showed how each one's calculated, and it took like 50 minutes. So I went through each one and talked about how each one is calculated. But yeah, mainly it's just knowing this output. And then we can do so much with code so easily. Like we can make predictions. We can do a check regression on it. And if you notice, all my code takes here is M. Just check the regression after the accident. Oh, thank you. Well, we'll end off right here because I got to end the video so we can get the next one going. But Evan, great work. Ask those questions during class. Let us know. Today, we're just finishing off regression. I need to speed it up. Well, you're learning it. Great work. We'll be back here in about 5 minutes for class. Bye for now, everyone. Bye.